Hello, 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 hello. चाय हम पीबे छै। चाय हम पीबे छै।
Recording in progress.
Hello everyone. तो चलिए स्टार्ट करें फिर आज का सेशन. Hope audio and screen is visible to audio. Am I audible or yes? And let's start it. So so already I think that you already have enrolled yourself into the course that is basically in the course section, so that if you haven't enrolled yourself, then you can please enroll it first, because after the session you will get this recording in this course 5-day free CCNA workshop. so that it will help you to get recording without any interruption. और इसमें कोई दिक्कत होती है तो फिर हम लोग बैठे हुए हैं, आपकी हेल्प कर देंगे. फ्री कोर्स है, आप इनरोल करेंगे एंड आपको वहीं पे सेम डेट सेम टाइम अपडेट आना भी स्टार्ट हो जाएगा. जब भी रिकॉर्डिंग प्रोसेस होगी और बाकी सारी चीज़ें होंगी तभी आने स्टार्ट हो जाएंगे. ठीक है, तो एक तो ये है. दूसरा, देन इफ़ यू गाइज आर वॉचिंग ऑन यूट्यूब देन वहाँ पे भी अवेलेबल रहेगा. तो 2-3 मिनट और वेट करते हैं, 2 मिनट और देन स्टार्ट करते हैं. ऑलरेडी हमारे यहाँ पे आप चेक करोगे तो कोर्सेज के अंदर रिकॉर्डिंग्स ऑलरेडी है. या आई कैन स्पीक इन इंग्लिश कॉप्स, सो नो इशू. थैंक यू. So and you will get everything there, okay, like either it is document related notes or videos. You will get everything in course section only. So during the class I'm not going to check the chat, and I will check after some time. So hope you guys understand about it, because I am working on a single screen, so it's not possible to watch everything. So let me start it, the day 3 of our this class. And today we are going to discuss about layer 2 layer 3 switches. Hope you guys understand about layer 2 or layer 3 switches, how it is actually physically how it is look like. So today we are going to discuss about in a brief, so how it is going to be function in our network, and what kind of thing we can do by using this kind of switches. If we will have time, then we will discuss about access point as well. If not, then we are good to go. Okay, and let me start today's session. So first of all, let me open the presentation so that it will help us. So hope screen is visible, right, to everyone? Like are you able to see the screen properly or not? Just please. Yeah, okay. So yeah, thank you all, and let's start today's session. So what is this? Okay, leave it, whatever it is. So welcome guys, welcome to Networking Scholar, and my name is Ramesh Kumar Sharma, and today we are going to start our day 3 session of free CCNA workshop. So basically we have already covered 2 sessions in last week on Saturday and Sunday about computer network, and computer network as well as how they are working, like physical devices, how it will look like, and various thing was covered in that videos. And if you haven't watched, then you can watch on YouTube as well as, and you have one more option, you can enroll yourself in the course and you can learn from there. So today we are going to discuss about layer 2 and layer 3 switch. So basically layer 2 and layer 3 switch is what? One second, let me take a pen. Today I am going to take a blue pen. So layer 2 and layer 3 switch, what it is doing, suppose that we have an user, not only user, suppose that hundreds users are there. Okay, 100 users are there in our network, and they all wants to communicate at a time without any failure or without going anywhere other network. In that case, what we are using switch. Just it will create a simple VLAN or simple network, simple broadcast domain, and that will help us to uh, share information between source to destination, or we can say that between one PC to another PC, one computer to another computer. तो जैसे कि बीच बीच में मैं हिंदी भी लूँगा, बिकॉज कुछ लोग हमारे साथ हिंदी में भी हैं। तो एक से जैसे हमारे पास दो पीसीज हैं फॉर एग्जांपल, और या फिर दो से ज़्यादा या 100 यूज़र्स हमने ऑलरेडी कनेक्ट किए हुए हैं, ठीक है। तो उस केस में क्या होगा कि हम एक स्विच को यूज़ करेंगे और स्विच का एक नेटवर्क बनाएंगे। डेफिनेटली ये सपोर्ट नहीं करेगा 100 यूज़र्स, सपोज दैट 24 पोर्ट या 48 पोर्ट की होंगी। इट कुड बी 24 एंड 48 पोर्ट, ओके। तो दिक्कत यहाँ पे पड़ने वाली है जब जब आप मैक्सिमम स्विचेस कनेक्ट करोगे। फॉर एग्जांपल फ़िलहाल के लिए हम ले लेते हैं कि हमारे पास 48 पोर्ट की स्विचेस, 48 ही यूज़र्स हैं, ठीक है। देन ये जब यूज़र ए चाहेगा यूज़र बी को कोई इन्फॉर्मेशन शेयर करना विदाउट एनी इंटरप्शन, देन यहाँ पे ये पॉसिबल है बाय स्विच के अकॉर्डिंग, बिकॉज एक टाइप का वीलैन क्रिएट करेगा और नेटवर्क क्रिएट करेगा, सिंगल ब्रॉडकास्ट डोमेन होगी। देन वी आर going to talk about layer 2 switch. So layer 2 switch is that this is a just a network device, it is nothing else, okay। आपको ऐसा नहीं सोचना है कि नेटवर्क डिवाइस के अलावा और क्या करें, नेटवर्किंग में क्या क्या कर और कहाँ लगा सकते हो। नेटवर्क के अलावा बाहर कहीं यूज़ होता नहीं है जनरली, ठीक है। तो नेटवर्क डिवाइस है दैट्स ऑपरेट ऑन डेटा लिंक लेयर ऑन लेयर 2, बेसिकली इसीलिए इसको लेयर 2 स्विच बोली जा रही है, ठीक है। because of that, because it is working on OSI layer. We have already learned about OSI, right? OSI layer 2. So OSI layer 2 का नाम कौन सा है? डेटा लिंक लेयर, ठीक है। इसलिए और ये इसका प्राइमरी फंक्शन, व्हाट इज़ द प्राइमरी फंक्शन? इट सेंड डेटा पैकेट विद इन सेम नेटवर्क और लोकल एरिया नेटवर्क। we already explained about it. So it is going to send the data packet between same network, okay। And it based on what? Based on MAC address, media access control. Basically MAC address, full form of the MAC is media access and control. So based on media access control, it is going to take a decision about it. One second guys. Okay, then we have how it is going to look like in a network. So this is the switch. Here you can see this is the model number 2960G series, okay। So this is a switch model number. Here you can see this is the reset button. There are few LEDs. It is showing like sync, system, NVRAM and multiple thing. Here also there is a multiple LEDs are there. Suppose that whenever we are going to connect, for example if we are connecting something here, something in the sense cable, okay, in that case it is going to be glow like a green or yellow. We will see in a physical network only, because there is not an option to check this. As well as these are SFP module port, okay। In the back of the switch you will find the console port and power port for to turn this switch off and configure something if needed. और हम एक और चीज़ कर सकते हैं, इसमें एक मैनेजमेंट इंटरफेस बना सकते हैं, सो दैट हम इसको डायरेक्टली विदाउट कंसोल के भी मैनेज कर सकते हैं। वो सेकेंडरी पार्ट है, ठीक है। तो ये होती है हमारी एक जनरल स्विच, ऐसा दिखता है आपको नेटवर्क में, ऐसा दिखेगा। देन बात आती है हमारे लेयर 2 स्विच कॉमनली कहाँ यूज़ होता है? टू इंटरकनेक्ट कंप्यूटर्स, printers, servers and other network devices like, one second guys, something is wrong today as well. Access point is there, server already completed, okay। Switches, routers, firewall, etc. There are multiple phone, IP phone. We can use this kind of devices to we are using this device to interconnect these kind of devices, okay। There are many more devices as well, like a PO injector हम connect कर सकते हैं और बहुत सारी चीज़ें हैं। So then what क्या क्या कंपोनेंट क्या क्या होते हैं, जैसे कि हमने राउटर के बारे में देखा था कि राउटर में व्हाट काइंड ऑफ कंपोनेंट्स आर there in a router. Similarly, we have multiple components in switch as well. Like first is switch fabric. Switch fabric is that when it is just architecture to the it is based on that it is going to forward packet to the in the network. Okay, so this is called switch fabric. Then we have, it's consider hardware it's consist of hardware components such as ASICS, application specific integrated circuit, or we can say that FPGA, field programmable gate array. It is similar like we have learned about gate and NOR gate and gate look like that. So it is working on like that. Okay, to perform switching forwarding operation at wire speed. Suppose that something is coming for some different VLAN and we have it wants to go on another VLAN, then it will check for this kind of the thing, like it will trigger something. Okay, then there is a ports. So what is port? हमने देखा था port is that where we are going to connect some cables. Okay, there was that was 48 port switch which already we seen in the last slide. So these are the ports. So port sometime it's also called interface. Okay, okay, interface, it's also called interface, port or interface. So ports are physical interface on the switch where devices such as computer, printer and other switches are connected. We already explained about it. So suppose that we have to connect a device, network device like a router, firewall, server, okay, IP camera and IP phone. Okay, these kind of devices, suppose that we are going to connect. In that case, it will only connect on port or interface. Okay, such as computer, server, printer or other switches, like if we want to we have a switch 48 port and we want to upgrade up to 90 user, for suppose that 90 user. Okay, then what we are going to do, we are going to connect 48, one more 48 port switch here, then it will be 96 around. Okay, and one port is used for connecting between switches. Then how many interface we will have? We will have 94 ports. Okay, so to connect switches as well we can use the ports. Okay, we will discuss in a diagram in a just in a few seconds, after few seconds. So then what is capacity of the port? So port capacity could be 100, 10 as well, 10, 100 or 100 mbps. Suppose that we can say that 10 mbps link, 100 mbps link, 1 gbps link. So, or if there is a higher port, like there was a SFP port, right, in the right side of the switch, there was a 4 SFP port, so it can support up to 10G based on your model number, device model number. If you have lowest interface speed, then you can use the general interfaces between 1 to 24 or 48 ports switches. If you have more than higher speed like 10G if you are using, or 5G 10G if you are using, then you can go with the SFP model, SFP based interface. Then there are MAC address table. So basically what is MAC address table? MAC address table is the physical address of every device, okay, that is MAC address. But switch is going to take a decision based on MAC address as well. Like how, suppose that something is connected, some devices are going to we are connecting on switch, so it should have a MAC address to make a MAC address table on the switch. So because so it's called MAC address. Why it is connecting? Because it's work on layer 2. We discuss about layer 2, right? So layer 2 protocol, there are MAC address is the layer 2 thing. Okay, layer 2 component. So it will take decision as per the MAC address, and it will forward data as per the MAC address only. There is not required for layer 4, layer 3 routing and anything like IP address as well. So they are not required for IP address. Only MAC address can work here. Based on MAC address, it can take decision. But you have to think about it. It is not going to work only for MAC. it is not apart. Suppose that someone is thinking, if suppose that it is working for a switch, a layer 2 on based on MAC address, then other will be denied, like layer 4, layer 3 and layer 7 traffic will be denied. No, it is not going to deny, it is just taking forwarding decision based on MAC address. ये सिर्फ मैक एड्रेस के बेस पे ही फॉरवर्डिंग डिसीजन लेता है, ना कि आपका पूरा का पूरा ट्रैफिक को डिनाई करेगा और बेस्ड ऑन इसके ऊपर काम करेगा. ओके, एंड बिकॉज ऑफ दैट इट्स ऑल्सो कॉल्ड मैक एड्रेस टेबल, ऑल्सो कॉल्ड व्हाट, CAM, content address memory table. It is a database maintained by the switch and that map what MAC address to interconnected switch port. Let me tell you let me show you an example. We have 12 port switch. Okay, I'm just trying to make a diagram 4 and 5. So here this is 1 2 3 4 5 6 7 8 9 10 11 and 12. Okay, these are the interfaces or port we can say. Okay, suppose that something connected, that is MAC address is AA, one PC1 is there, PC2 it is BB, okay, PCC there is CC, 3 on 3 and DD. Then how it is going to build a MAC address table? It will take a table like just a second guys, who is sending a message? No, I don't think so. Am I not audible? वॉइस का इशू है किसी को? Am I audible properly or not? I'm not audible. Hello, 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 hello. Hello, hello, hello. Hello, hello. Am I audible, right?
Your voice is, yeah, Ramesh, your voice is audible, but it's cracking in a while. Can just everyone confirm, please?
Okay.
I think I might have a network issue here as well.
Maybe. Thank you, Manoj. Basically, what is happening? We are streaming multiple platform, na? That's why maybe it could be a reason of that. It's okay. So you will see in the recording as well. So for time being, this is good for us. So okay. So how we are going to build a MAC address table? Okay, MAC address table. So we are going to discuss about it. Let me open. Where was I? Okay, here I am. So how it is going to build a MAC address? So it will build MAC address based on port and interface. So it will suppose that how it will going to address. This is the port and MAC. So on port A is connected. Port 2 what is connected? BB. Port 3 CC. Port 4 DD. It will look like it will create database look like that. Okay, so whenever suppose that something is coming, suppose that A wants to communicate D. Okay, then how it is going to work? It will check for port number. Incoming port will be 1 and outgoing port will be 4. Okay, then it will forward based on MAC address. It will send the packet based on MAC address table. How? Because we already have a CAM table or MAC address table, so it will take decision without any taking time, and it will forward the packet to the destination port number. Okay, so this is called MAC address table basically. So and then based on, we already discussed about it. Then there is CPU and memory. So what is CPU and memory actually? CPU and memory is same thing which we have like we are using mobile phone, right? We always trying to get like how many RAM we have, how much RAM we have in our mobile phone, or what is the storage, like 8 GB 126 GB, sorry, 256 128, or 4 GB 128, 4 GB 64 GB. So there are similar thing which is also in our network switches as well. It's called CPU and memory. CPU and memory is why we are using, because it is processing something. How it is going to process? Without CPU it is not going to process anything. Suppose that if we have CAM table, but how it will create? There should be a memory or something, right, to maintain this table, as well as if there is something database is there, then definitely we have required what, CPU to process, central processing unit to process this information into binary to decimal, decimal to binary as per the requirement. So for example I am saying, so there are CPU and memory there are two type of memory. RAM is able to use to perform temporary task, and ROM is able to store, okay, store what, configuration and configurations, as well as databases, whatever it is. So it is going to be work like that. So because of that reason we have required CPU and memory in our network. Then बात करते हम, then we are going for a next topic, that is management interface. We already discussed there is console port, then why it is management interface is required in the switch. So management interface is required for that. Suppose if console port is behind on the back of your switch, and you always, if you have to configure something, or if you have to create a new VLAN, or you have to shut down one interface or something else, in that case you have to go and plug the console cable, and you have to first, you have to what, you have to remove the cable, sorry, switch from your rack, from your case, and after that you are going to connect the console, and after that you will configure it. Suppose that what if we have management interfaces, then what it will help, it will do, it will help us to configure without removing switch from the rack, without putting console on the switches, okay, switch port and console port, and we can configure it. So switch management port is working on based on CLI, as well as command line interface or graphical user interface. It is also helping us to manage what, manage to monitor the devices and traffic as well, okay, and it will also help to what, troubleshooting issues. Suppose that, for example, troubleshooting in the sense, suppose we are shutting down interface, or we are creating a VLAN or something, in that case it is going to be work. So management interface is also important part of our switch. Then there are few more thing, that is called function. So how it is going to be function in our network, ये function कैसे करता है हमारे network में basically. तो function करेगा based on ये आपका कुछ frame देखेगा, and then इसके बाद चीज़ें check करते हैं. Then first it is going to be frame forwarding. So how it is going to what is actually frame forwarding, and how it is working in layer 2 switch. So let me explain and let me show you the thing. Layer 2 switch forward data frame between network devices within a same LAN based on destination MAC address. Same LAN on based on destination MAC address. So one second guys, I think I am facing an issue. Video. Rahul, can I stop video to join us, for joiners who is going to join? So stop video. Okay. So okay. Then in the same LAN, suppose that we already discussed we have 24 or 48 ports. So if we are not configuring any VLAN, then I will share you some cheat sheet on this course section. You will find it. So what actually packet call on which layer, either it is based on OSI or TCP/IP model. Okay. So this is the thing, how it is going to work. They use MAC address table. Okay, let me erase it first. So this is using MAC address table to determine outgoing port for each frame. It will always check, okay, it will always check for MAC address table. So you guys must understand about MAC address. If you don't know, then you can please watch this video again, what is actually MAC address. So okay, I will post I will upload a short document about the MAC address table. So what is MAC address table and what is actually that will be in a brief, so you will find in the course section. Okay, so based on MAC address table, it is going to send frame to the destination outgoing port. Okay, am I audible, or maybe it's disconnected something? Hello. Okay, I am audible, I think. Okay, thank you. So let me open my chat here. Okay, so what it is doing, it is minimizing unnecessary broadcast traffic. Suppose that we have a single VLAN. VLAN 1 is there only configured. Suppose that it is connected VLAN 1 to 21 port is configured for VLAN 1, and suppose that we have also a VLAN called VLAN 2. Then what it will do, it will not going to process frame in other VLAN. Unnecessary broadcast, this is unnecessary for this port, and suppose that 22 to 24 is a part of VLAN 2, then it is VLAN 1 is unnecessary for VLAN 2, and VLAN 2 is interface traffic is unnecessary for VLAN 1. So it is going to be work like that. It is not going to allow to forward in different VLANs. Okay, so this is the thing can be handled by switch. Then there is MAC address learning, how it is going to be MAC and what kind how many time it is going to learn about the MAC addresses, how much time it will take the MAC address table in their entry. So basically MAC address table entry will can be stored by a single switch or ARP entry by switch at least 4 hours. Okay, this is default setting of the switches, but you can change as per your requirement. So layer 2 switch dynamically learn MAC address by examining source MAC address of incoming frame. Now let me explain how. Okay, this is our switch, this is FA0/1, FA0/2. Okay, this is AA and BB. IP address 192.168.1.1, 192.168.1.2. Don't think about the IP address right now. We are not talking about IP address. Just focus on MAC address. Suppose that AA or 1.1 is trying to ping BB or 1.2. 1.2 why I am taking this is the IP address without at least we have to complete layer 1 to layer 7 and layer 7 to layer 1. Okay, without this it is not going to without completing all the step, it is not going to forward as per the OSI model. Similarly layer 1, layer 4 to layer 1 and layer 1 to layer 4, it need to be completed. Packet will go everywhere on each layer and for in TCP/IP. Okay, so it needs it will complete. Till then it is not going to complete the full process or full process in OSI or TCP/IP. It is not going to forward anything. So here is what, suppose that A is trying to ping BB or 1.1 is trying to ping 1.2, 1.1 is trying to ping 1.2. Then what it will check, how it is going to work. So then how it is MAC address is learning. So MAC address will learn, suppose that something is created from here and it is where it is forwarding to. First it will go to the switch. So in this packet there will be some information like source MAC, okay, destination MAC and frame, okay, as well as source IP, destination IP, frame in the sense packet, whatever is the data, actually data. Okay, then it will check how it is going to learn. It is dynamically learning. Okay, suppose that something is happening, I don't know what is this, but there is something. I'm getting ring. Okay, so no issue. Then okay, so first it will going to learn dynamically how packet came from someone, sorry, packet is coming from a PCA and it is going to the switch. Then it will learn for like source MAC address. So it will create entry FA0/1 have what source MAC address is AA and IP port number is 0/1. Similarly it will first it learn, okay, if for a from where incoming data frame, it is incoming data frame, it's learn. and then it will check for other MAC address or other IP address. So we are using just L2 switch, so we are just focusing on MAC address. So after that it will create for what? It will allow us to share information. It will allow us to get the MAC address of BB. So it is some kind of R process, so we will discuss later about it. Okay, so how it is going to be learn about from incoming data frame. When the packet is arrived, the frame is arrived at the switch port, switch will update MAC address table. Okay, definitely suppose that we have changed our PC on fast Ethernet 0/1. Then what it will do, it will again, it is going to the same thing, and it will update the MAC address table and it will remove the last entries. For example, the new PC MAC address is ZZ. Okay, then it is going to be remove the entry of A, and it will add a new entry on fast Ethernet 0/2, 0/1, that is ZZ. Okay, with the source address and corresponding port information, allowing to build forwarding database for future frame forwarding. So suppose that till then this PC is connected on FA 0/1, everything will be good, and it can be shared by it can share information without losing any frame or something, we can say that. Okay, then there is broadcast and multicast handling. So broadcast is what? Suppose that if we have it is not going to support, suppose that we are using hub. So earlier in the few years back there was a hub already also in a network. So what it is doing, it is also trying to send frame every interfaces. So let me explain. It was sending, suppose that we have a PC, we have 5 PC connected here. Okay, so suppose that this PC is trying to send some information on, this is 1 2 3 4 5. So PC 1 is trying to send something on 3. Then what it was doing, it was sending frame to the every interface every time. Or suppose that 4 is trying to send something on 5, so it should be direct go to the look like this. Okay, but what is it is doing, it was sending to every interfaces. So it was what it was doing, it was sending it was creating a broadcast, and it was saying an annoying it was doing annoying thing. So to reduce this thing, it is also help us, layer 2 switch help us to remediate the thing, like it will disable like broadcast and multicast handling. So layer 2 switch handle broadcast and multicast traffic by forwarding this frame to the all port within the same LAN. If it is in same LAN, then it is fine. If it is not in same LAN, same virtual local area network or same local area network, then it is going to be discard, except incoming port. Suppose that something is coming from FA0/, so it is not going to forward that frame or that broadcast frame to this interface, because it's know about it. So it is coming, the frame or packet is coming from FA0/1. And let me erase it. Then we have, it will ensure for what? Broadcast and multicast traffic reaches all the devices with the broadcast within the broadcast domain. Suppose that in a VLAN 1, okay, we have 2000 of users. If multiple switches are connected here by using trunk port, okay, then what it will do, it will share their broadcast only those interfaces where it is actually where is VLAN 1. It is not going to share on VLAN 2, VLAN 3 or XYZ, anything, any VLAN. Okay, so it will ensure for that as well. Let me erase, all of the time I have to erase this thing. Then VLAN support. So layer 2 switches can support VLAN as well, like if we want to create multiple VLAN, that it can support, but at a time only one VLAN is going to work. Okay, we will discuss and we will learn about it in a physical network. Basically you are going to understand. Hope if we will get some time today, then I will show you how it is going to be work in a topology. I will build a topology later. So okay, so layer 2 switch support VLAN, which is a partition of a single physical network into a multiple logical network. For example, this is a good example I am going to share. We have 24 port switch, 8 port belongs to admin. Okay, 8 port belongs to 8 ports are there. Sorry, 32 port or 6 we can say that 6. Then it is 24 port, 6 admin, 6 sales, 6 is for IT, and 6 is for user. Okay, so suppose that if something is there related with admin, then we can, by using the VLAN concept, we can limited our interfaces to share their broadcast entries or share their information in within limited interfaces. For something is for sales, then it will be only limited interfaces for 8 or 6 interfaces. Similarly, we have like what is that, IT. Okay, so IT users can be connect and they can share their information within their LAN, and because of that it is not going to share all information to this in this VLAN, the user VLAN or sales VLAN or admin VLAN. It is only going to be participate in this VLAN only. It is not going to be participate in other VLAN. Okay, so this kind of the thing can also managed by layer 2 switch. VLANs enable support switch layer 2 to work for what it is supporting us to create segregation or and for partition as well. Okay, so VLAN enables network segmentation, isolation and security by logically separating traffic into different broadcast domain. We already discussed, like if we have 24 port, then we have separated in 4 ports, 4 different group. Okay, so these kind of the thing can be happen, and if if we want to do, then we can use VLAN for segregation. Then there is a spanning tree protocol. A spanning tree protocol is what? You see that I draw 3 or 4 times and the same similar diagram. Okay, like we have switch 1, switch 2, switch 3. Suppose that something there is connected, that is connected through a trunk. This is trunk interface basically called. Okay, to share all kind of VLAN traffic between switch 1 to switch 2, switch 2 to switch 3, switch between within a network. Suppose that what is happening here, by some reason cable got broken, or by some reason interface got shut down. Then what will happen? Switch 1 traffic, suppose there is a user and there is also a user. There are 3 users, okay, on different location. They are in the same group. They are admin actually. Okay, admin. They are sharing some information, and during this sharing data, cable got broken. So then what will happen? It is not going to participate from source to destination. Either it is sending from here first switch to second switch, or second switch to third switch PC or administrative PC. Then what we have to do, we can put another cable between the switches. So to for redundancy purpose, like if suppose that something if in case one cable is get broken or switch interface goes down without any logic, or we can say that someone by mistake, someone what he did, he just shut down that interface or trunk interface. Okay, then it will help us to share information without losing our time, or our network resource will be always up and running. So suppose that if some traffic is coming from this PC. Okay, let me change the pen for now. Something is coming from this PC and it is sending to the switch. Okay, how it is going to share? And then it will share information to this switch, this interface, and as well as suppose that there is a PC connected except on this interface. Okay, then how it is going? It is passing to the switch to switch. Okay, and what it will do? This packet will send to this switch, and this packet will send which is coming from here. Okay, so what it will do, suppose that something is coming from this line, it is going to be shared on this interface, and if it is incoming, then it will be other different switch. So it will create a loop. To prevent this loop, here what we are going to use here in our network, a spanning tree protocol. A spanning tree protocol, what it will do, it will allow us to reduce our network broadcast, or it will allow us to enhance our switching capacity for users. Okay, so layer 2 switch implement a spanning tree protocol, or it is a variant such as rapid spanning. There are multiple spanning tree protocol in the network. That is rapid RSTP, MSTP, which what we are going to use. Okay, so that's you already understand about it. So it is going to create a loop, and till then we have it is not it will consume all of the bandwidth of that interface, and communication will be stopped from source to destination. Okay, to reduce this thing we have to use what? A spanning tree protocol. Okay, so then we are going to discuss about next function of our layer 3 switch, that is link aggregation. Okay, link aggregation. So how link aggregation or ether channel is going to work? We already drawn the diagram. Okay, in the last slide we have switch and we have connected two interfaces. Suppose that this interface belongs to 100 Mbps and this we have 100 users, 200 users in this segment, or this is a building, there are 200 users, there is also 200 users. Okay, or suppose that there is 100, let's take an example, 100. Then what we will do, if suppose that they are sharing in data from this building A to building B, and then what will happen, it will share information. There is not an issue, but it will create what? It will create something like it will laggy. Suppose that sometime it will send 1 Mbps traffic and sometime it will say 1 kbps traffic or 1 kbps data. To reduce this thing we can use ether channel. Ether channel can do one thing, it can bundle the interfaces into a single link by using single link. Either it is trunk, so it is also helping us to for redundancy as well. It is also adding one thing, what that is, it is increasing the bandwidth. Suppose that this was interface was 100 Mbps link, and also we have connected one more interface that is 100 Mbps link. Okay, so now what is the bandwidth, total bandwidth of our connected switch connected link between switch 1 and switch 2, that is 200 Mbps, and user can share information like 1 Mbps for example without any interruption. Okay, so this is this kind of the thing done by link aggregation or ether channel, and it is also we can configure that link as a layer 2 trunk port as well. Okay, so layer 2 switch support link aggregation or ether channel which combine multiple physical layer link into the between switches. Okay, so this is just I'm taking this slide just for reference. Suppose that if you are not going to understand my voice or something, it is lagging, in that case it will help you to create a note for you. Okay guys, then link aggregation increase bandwidth, we already discussed. Enhance network reliability, because suppose something is getting one cable is get broken or down, then in case it is also going to work similar as a STP. So, and it is also setting the load balancing based on MAC address. It is taking decision. Suppose that something is from AA MAC address or BB, so it is going to discuss. So bandwidth increase for that thing we will deep in dive in a few after few video after few lecture. There is a separate topic of ether channel, so till then you guys have to wait for it. So how it is going to work we will discuss on a very brief in that, because of layer 2 switch we are discussing today, so we are not going to take that thing here because it will be totally lengthy. So then there are some features as well. It's called port security. So what is port security? Suppose that this is a switch and there is a users are connected. One day one desk, this is your desk. Okay, you are not on your desk and you are on absent leave for some reason. Suppose that someone came from outside and your security guard did allow him to come in your premises, in your office premises, and what will happen, what he did, he just connect here his laptop in the network cable, network IO port, it's called input output port, and what he is trying to use that in there, use his laptop as a DHCP server or FTP server, something else. So to steal information about like credential, user information, user data, or something which is very important for your organization or your network. So by using port security, what it will help us, it will we will bind MAC address on the port. If the user, suppose that your MAC address is XYZ, okay, and its MAC address is ABC. So we will bind XYZ on port number. Suppose that this is your port number FA10/0/10. Okay, so we will bind XYZ on FA0/10. If someone is connected their PC on this interface, if it is not matching the MAC address, then what it is going to do, it is going to be error disable or blocking state. So we will also configure, this is a part of our CCNA course, so we will discuss there everything about it. So basically this is just a feature to enable MAC filtering. It is also called like MAC filtering. If it is not based on that's why I explain everything about how it is going to work. So okay, so if it is not going to be checked, the packet is not coming from that MAC address particularly, then it is going to be blocked by the switch. Okay, like it is using like DHCP attack or something, so it can do by them. Then there is a storm control. Storm control is what? Suppose that some DHCP, there is an attacker, it was trying to sending information about DHCP packet multiple time. Then what it is creating and the broadcast packet and broadcast, okay, in the switch. And because of why it is doing like that, to consume all of the bandwidth of this interface. Either it is 1 gig, 100 MB, 10 MB, whatever it is. So suppose that there is something storm, it's called like flood. Okay, so if there is the user is sending something that is not a new for use, and it is what it is doing, it is just consuming our interface bandwidth or connected interface bandwidth. Then in case we are going to use a storm control, so what we will do, we will configure a storm control on interface. Suppose that if 80% bandwidth consumed, then it will discard the if something is there connected on the switch, if 80% bandwidth its uses of its connected interface, then it is going to be block that interface. So look like that it is going to work in our network. Okay, so a storm control is a mechanism of layer 2 switch. Okay, so what it is going to do, it's mitigate the broadcast, multicast and unicast storm by limiting rate of incoming traffic to prevent network congestion and disruption. Okay, hope you understand with the example what I said. Then there is IGMP snooping. IGMP snooping is that internet group management protocol called that. It's called internet group management protocol. So it is doing it is also a snooping. Okay, so it's listen IGMP messages exchange between host and multiple routers. Something if that is not related to the router, it is going to be discard. Okay. Then there is loop prevention mechanism. Loop prevention is a similarly like STP, or there was a loop prevention mechanism, but there is also one thing called BPDU guard, Bridge Protocol Data Unit. It is what it is doing. Suppose something is someone is trying to make their laptop or devices or workstation as a root bridge. In that case, it is going to be used to prevent our network. So it will also prevent our network. Okay, by enabling, because we know we can take we can configure our STP root port, and we can change their values at a time, like if it's 32768 and if we want to configure change the root bridge ID, then we can do that priority as well. So because of that reason we are using BPDU guard. If something is coming BPDU guard, then it will going to be blocked. Then there is virtual stacking. So we will what is virtual stacking? Suppose that we have multiple switches. Okay, switch 1 and switch 3, there are 3 switches for example, and it is just we want to manage as a single by using single management interface, or to reduce our IP addresses as well as management console. So in that case what we can do, we can do virtual stacking of those switches, so that we can manage this switch by using single console or some and it will also help us to create a single database. Okay, some layer 2 switches support virtual stacking or stacking, but this is depends on their configuration or based on model. Not every switches are going to support this thing. Okay, so either it we can use for virtual stacking, that is ethernet, or there is a stacking cable. Okay, so we can use both of the thing. Let me show you an example how it is going to be look like and how it is showing. So here you can see the virtual stacking is it will look like this. So here you can see this is switch 1, switch 2, switch 3. Here you can see this is the port of console port. There is a console port and management port. Console port and management port, there are two ports. But what will happen if suppose that we have to this is on a single rack and we want to configure at a time, then we have to use this kind of thing. So this interface is called stack interface. Okay, okay, so how it is connected? This is connected from this PC1 to PC2, sorry, switch 1 to switch 2, and then switch to switch 3, and then switch through switch 1. And after that, this is called in a single virtual switch. Okay, single virtual stacking is this, and we can manage this switch by using single console or single management IP. Okay, here you can see this is the USB. If we want to upgrade this switch, then we can do upgrade from here as well. There is something look like that. So guys, hope you understand. We already discussed 1 hour on the switch, and after that we have to go for layer 3 switch. So if you guys are agree, then you can take off 5-minute break, so that basically it is lengthy and we are going to discuss everything in a deep. So just take guys 5 minutes, and I'll come in 5 minutes at we will meet at 10:05. Almost 10 minutes we have, sorry, 9:05. So okay, if you have till then, if you have any question, please chat us, and let me come after the break, and I will discuss on it related layer 2 switch, if you guys have any issues or any concern about it. Okay guys, let's see you after 9:05. No, meeting is not paused. I was waiting. So can we start now? If you guys are available here. So let's start because I came back. If you want, then I can wait for a minute as well. So just let's go to the next section of our layer 2 switch. Okay. So first of the thing, there are some use cases of layer 2 switch. That is basically this is lengthy. I am going to discuss everything, so it is taking time. Okay. It is working. Okay. Yeah. So there are some use cases. So first use case is local area network. So local area network, we discuss about it like it will be a single broadcast domain, and everything which what we are going to discuss, share information. Suppose that PC1 is and PC2 was sharing their information in a single domain. Okay. So in that case, it is going to it will be a part of, suppose that this is a belongs to VLAN 1 and this is also belongs to the VLAN 1. So this is a kind be a part of local area network, a single local area network. Okay. And layer 2 switch are commonly used in a LAN environment to interconnect computer, printer and server. We will already discuss about it. So just I am going forward. Then we have edge switching. So what is edge switching? Edge switching is a different concept. Let me show you everything. So let's switch layer 2 switch servers. What is it is going to be servers? It can be it can work as a layer switch, edge switch as well. Okay. In the network architecture, connection end user devices such as desktop computer, laptop, IP phone and wireless access point. Why it is called edge? Because this is just entry point of for users. This is entry point for every users. So because of that, it's called edge switches. This technology called edge switching. Like we will see there is a edge router. Okay, we will see in the sometime. So this is why it is called edge router, because this is front of internet. Because of that, it's called edge router. So similarly, which is nearest to the user or nearest which where multiple things are coming, that or traffic is coming, so it's called edge actually in the network. They provide connectivity device to device at the network edge and enforce network policies and security measures at the access layer. Basically access layer is access layer is that layer. Suppose that in architecture, like we have three tier architecture: core, then there is distribution, and there is access layer. Okay, so it is going to connect every switches, and let me change the color of pen. And okay, so this is called layer, access layer. Okay, so the as access layer, this is called edge switch as well. Okay, hope you understand about it. That's why I make the diagram. So devices can be connected directly here. Devices are connected directly here. Suppose there are multiple users, they are connected. You understand, I think. If not, please you can ping so that I can share, I can let you know again. If yes, then I'm going on next slide. Then how it is, there are IGMP snooping, we already discussed about it. Then we have what? Distribution switches. So distribution was that on the already discussed on where layer 2 sorry, there was three tier architecture: core, and there was distribution.